Now we're going to start talking about how to actually solve quadratic word problems. And there's two main types of problems that you could see. One of them is called projectile type problems, which is where somebody's either like throwing something up in the air or something's being shot into the air. And then there's some business type problems that might deal with like profits that a business is making, okay? So before we can actually get into these types of problems, we have to talk about, the different parts of the graph. So when something's thrown into the air, typically it's going to make kind of this shape in the air. So it kind of goes up and then it reaches that maximum height and then it falls back down to the ground, okay? And so we're going to talk about some important points that you're going to see in the graph. So whenever you graph this, notice it looks like a U. So that's why quadratic functions come into play here, is because when you graph a quadratic, it looks like a U, okay? And so the three main points that you're going to see when something's being thrown or shot into the air is the first point, which is the y-intercept in this problem. That's when like the time was 0. So at the very start of when it's thrown or shot into the air, this would actually show the initial height. So it could be thrown by somebody, so that would be like however high the thing is from the ground, however high their hand was. Or if it's shot into the air, sometimes it could be put on a platform and shot into the air, or this point could actually be all the way down here and it should be shot from the ground. And so the y-axis is how high it is from the ground. And so the x-axis you could actually kind of think of as the ground in these problems, okay? And so that point right there is going to show the initial height of whatever is being thrown, okay? This point right here at the very top should be pretty obvious. It's going to be however high it reaches. So the y value there would be the max height that it goes. And then the x value is your time, because the x-axis in these problems is usually going to be time. And so this point would tell you the time that it reaches its max height, essentially. And it's also going to tell you the maximum height that it reaches. And then it kind of goes up, it reaches that max height, and then gravity starts to take over, and then it falls back down to the ground. So this point right here, if you look at the x value, would tell you the time that it hits the ground. And so this one's going to have a number here, and then the y value will actually be 0 because the height above the ground is 0 there. Okay, so those are the three important points that you'll need to know about when something's being thrown or shot into the air, or projectile type problems. Okay, the other type of problem that you might see is dealing with businesses. So when it's talking about a business, the points will kind of change. So usually the x-axis is still going to represent your time, but this time the y-axis is usually going to represent the profits that they make. So the profit that a company makes is after a company or a business has kind of paid off all of their debts. This is the point where they start making money, okay? So the first point, that point right there, is going to represent the time that they actually start making a profit. So after all their debts are paid off, at that point, that's where they break even, and now they're going to start earning money. And then at the very top here is representing the time that they make their max profit. So the x value will be the time. The y value will tell how much they made, or the most that they made at any one point in time. And then this last point right here is actually the sad point for the business. That would be the time that they stop making profit and they actually start going back into debt. So this part of the graph would be like them actually going back into debt. Okay, and so those are the three kind of important points that you're going to see in these problems. So what we're going to do now is start practicing finding some of those points, okay, using what we did in the last video. So when you're given a problem, you need to read through it, then maybe even draw a little picture to kind of help you see it, and then you answer the problem. So it says the function, and then they give you the equation, represents the height of a ball t seconds after it is thrown. So this is one of the projectile problems, so kind of look over there to know that. It says, what is the maximum height the ball reaches? Okay, and so you have to kind of know a little bit about these if you want to sketch it. So if you're trying to sketch it, if you kind of review, this is in standard form. And so remember, standard form, that number right there actually tells you the y-intercept. So we already know that the y-intercept is 1. So that's where the ball, if you look up here, that's actually where the ball is going to start. Okay, so we know it's going to hit the y-axis at 1. Okay, and then we also know by looking at this number, because it's negative, we know that it's going to open down. So I can at least do kind of a sketch here. I'm not going to be able to be super specific, but I can at least sketch my picture. So it opens down, and then I know it hits the y-axis at 1. So if I kind of sketch my picture, I got to make sure it goes through there, and then it's going to kind of look like that. Okay, so I can at least kind of see a picture. So this problem's saying, what is the maximum height? So look up here. Where do you look? So if something's thrown, it goes up, and then it comes back down. Well, the maximum height, we're technically looking for this point right there, which is the vertex of my parabola. So I'm looking for that point right there, okay? So if you looked at the other video, we talked about how to find the vertex. So to find the vertex, remember, you have to remember that it's a coordinate, so it's going to have an x and a y value. And then there was an equation to help you find the x, and that's where we have to start. So you might have to go review, but the equation to find the x part of your vertex is that right there, negative times whatever your b is over 2 times a. So all I have to do is plug that in, and I'll find the x part, and then I'll be able to find the y part from there. So it'd be negative times, okay, well, what's my a and my b? So my a is the number in front of my x squared, so it'd be negative 2. And then my b is the number in front of x, which is the 8. Okay, so it'd be negative times my b is 8. And then that's over 2 times my a is negative 2. And then I just simplify. So that would end up being negative 8 over 2 times negative 2 is negative 4. So negative 8 over negative 4 is 2. So that is the x part of my vertex. So if you look up here, that's actually the time that it would have reached the maximum height. So we know that it reached the max height after 2 seconds. Okay, so that's that part. But this is not what the question's asking us. It's asking us what is the maximum height. So we're actually looking for the y value. So what you have to do from there is take, if you look at the other video, you take that and you plug it into your equation for your x, which is a t in this case, to find your y value. So I'm going to take, and I'm going to plug in a 2, so it'd be negative 2 times, plugging in a 2 there, so it'd be 2 squared. All I'm doing is copying this equation right here, plus 8 times, plug in a 2, and then copy down my plus 1. And then from there, I just simplify. So this ends up being 2 squared, which is 4, and 4 times negative 2 is negative 8. And then we add that to 8 times 2 is 16. And then bring down my add 1, and then we just simplify from there. So negative 8 plus 16 is 8. So that'd be 8 plus 1, which is 9. So that is the y value of my coordinate. So kind of coming back up here and putting it all together, we were looking for that point. We found it. It was at 2, 9. And so if you look up here, the x value is the time, and then the y value is the maximum height. And so it says, what is the maximum height that the ball reaches? Well, it would be 9. And then let's see if they give us units for that. Represents the height of the ball. It doesn't really give us units, so we will just put the general word for units. So the maximum height that it reaches, this would be the maximum height that the ball reaches, would end up being 9, and if it was like feet, you'd say it reached 9 feet high, or if it was, I don't know what other types of units it could be, but it's 9 units, okay? And then if they asked you what time did it reach that, you would say after 2 seconds, okay? So let's do another problem. The next one says, the formula, and then they give us the equation, represents the height of a rocket t seconds after it is launched. What is the horizontal distance between the zeros? So this is a problem that we've done before. And so something you need to remember is when it asks us for zeros, they're really asking us for the x-intercepts. So they're really asking us to find the x-intercepts here. Okay, so think about the other video that we have 3 different ways to find the x-intercepts. If we didn't have a calculator available, we could try to do it by factoring, or we could try to do it by square root method. If you look at this equation though, because we have the bx term, that eliminates the square root method. So what I'm going to have to do is I'm going to have to try to factor this, okay? So to find the x-intercepts, we're going to try to solve it by factoring. So I'm going to just copy this down, and then remember, instead of this, which that's the same thing as y, I'm actually going to, instead of this, I'm going to put a 0 like I did in the other one. So I'm going to just copy that equation down just as it is, and then I'm going to put an equals 0 at the end of it. Okay, then I'm going to try to factor it. So the first thing with factoring, remember, is always look for a GCF, and this one actually does have something in common. And I also talked about if there's a negative in front of your leading term, make sure you factor that out. So I'm going to take that out, but then what else do they have in common? Well, if you look, they all have a 3 that goes into them, so I'm going to factor out a 3, and then they don't have a variable in common, so it's just a negative 3 I'm going to factor out. So you divide each term by that. So this divided by negative 3 ends up just giving me t squared. This divided by negative 3 ends up giving me negative 5t. And then this divided by negative 3, negative divided by negative is a positive. And then 12 divided by 3 is 4. Okay, so that's the first step. Now, you have to look at this and see if it'll factor, and it will. And so that, remember, that negative 3 just kind of hangs out outside the parentheses. And then for these problems, it's a trinomial. So you just bring that and you start looking at what gives me first to give me t squared. So what times what gives me t squared? It's just t and t, and it's a basic trial and error because there's just a 1 in front of that. And then we look at our signs. That means that they're the same, and so to know what they're both going to be, you look at this sign. So I know they're both going to be negatives. This is reviewing of my trial and error stuff. And then you list out what multiplies to give me this last term, which is just 4 and 1, and then 2 and 2. So from there, you look at this, look at these signs, and you ask yourself, which of these will combine with those signs to give me that middle term? So I have to get a negative 5 out of it. And notice, if I take 4 or negative 4 minus 1, I end up getting negative 5. Okay, so now it's factored. To actually find the x-intercepts, you take each one of those parts and you set them equal to 0. Now, I don't have to take this one and set it equal to 0 because it doesn't have a t with it. And so I'm just going to kind of ignore that, and I take each one of these and set it equal to 0. Okay, if this did have a t with it, I would have to set it equal to 0, okay, but it doesn't. So now I solve. So I have to add 4 for this one to both sides, so t would equal a positive 4. Here I'd have to add 1 to get it to the other side, so t would equal 1. Okay, so those are your zeros. Those are your x-intercepts. So I know that it's going to cross the x-axis, and I'm going to put them in numerical order at 1 and 4. Okay, but that's not actually what this is asking for. But this will help. So if you go back and look, it says, what is the horizontal distance between the zeros? So think about it. It's a rocket being shot off, and if you notice, it actually would have a y-intercept at negative 12, so the y-intercept would be down here. So if I drew it, it'd be something like that because it's touching the y-axis way down there, okay? And so the zeros are where it's crossing the x-axis. So I know it crosses it at 1, so that would be like at 1, and then 2, 3, the other one's at 4. So that's what I know about it right now, okay? So what it's asking is, what is the horizontal distance? Horizontal distance is how far they are apart. So if you kind of, if you kind of sketch a picture of it, you can just count. So how far is 1 from 4? 1, 2, 3. So the horizontal distance would be 3. And if you even go even further, this is the time in seconds. So it's 3 seconds apart. So the way to kind of understand what's going on here is from the moment that it was launched, because this would be, I guess, where it kind of comes off the ground, to the moment that it hits the ground, there's 3 seconds between them. So that's really quick. It goes up and then right back down. Okay, so let's do one more, just so you can see one more by hand. It says number 3, the function, there's the equation. It says that models the approximate height in feet of an object so many seconds, t seconds, after it is launched. How many seconds does it take for the object to hit the ground? Okay, so if you go back up here, it's something else that's being thrown. So we talked about it kind of goes up and then it comes back down and it hits the ground. And it's saying in this problem, how many seconds does it take for the object to hit the ground? So we're looking essentially kind of from when it leaves, when does it go back to the ground? Okay, so we're kind of looking for this point right here, so which is an x-intercept. So that technically means we're finding the x-intercepts. So again, you have options. You could, if you had Desmos available, you could graph it. You could try factoring it. You could try square root method, but for this one, because it has the x term, you won't be able to do the square root method. Okay, so we're going to act like we didn't have Desmos, so that means we have to factor it. So you can kind of think through it. I'm finding my x-intercept, and I'm actually looking for, if you think about it, the second x-intercept. Okay, I'm looking for like how long since it was in the air did it come back down. Okay, so I'm looking for that second one, but that just means I have to find my x-intercept. So I'm going to copy that down like I did before, and I'm going to set it equal to 0. Instead of the f of t, I'm just going to set it equal to 0, and then I'm going to try to factor it. So just like before, does it have a GCF? And it does, and it has a negative up front, so you want to factor that out too. They've all got a 5 in common, and they don't have any variables, so just divide by -5. So that would end up being t squared. 15t over -5 ends up being -3t, and then 50 divided by -5, that would be a -10. Okay, so then I look at this and I see if that will factor. So that -5 just hangs out. It's a trinomial, so I'm going to see, is it a trial and error or a chin and grin? And so it's just a regular trial and error because there's a 1 in front. So t times t is t squared. My signs, because that's a negative, means they're different, so I can go ahead and put those in there. They're different signs. And then what multiplies to give me 10? Well, it'd be 10 and 1, 5 and 2. And that's it. And now I'm going to look, okay, they got to have different signs. Which of these will combine to give me that middle term, the -3? So notice if I put the 5 with the negative and the 2 with the positive, that ends up -5 plus 2 gives me -3. So now, got to solve it. So I take each of my factors and I set it equal to 0. Don't have to do that one because it doesn't have a t with it. And then I solve them. So here I'd have to subtract my 2. I'm going to have to write them over here. So when I subtract 2, t would equal -2. And then here I'd have to add 5, so t would equal 5. Okay? So if you kind of think through this, it says how many seconds does it take for it to hit the ground? So think about the picture here. We know that it's going to hit the x-axis at -2. So it's going to hit right there. And it's also going to hit at 5. 1, 2, 3, 4, 5. So it's going to hit right there. And then if you also look, because there's a negative in front of your t squared, it means it opens down. So if I kind of sketch the picture of it, kind of look like that. And so it's asking how many seconds does it take for it to hit the ground? Well, it goes up, reaches that max height, and then it hits the ground right there. So what is the time? Remember, that's the time that it hits the ground. Well, it takes 5 seconds. So that is your answer right there. It takes 5 seconds for it to hit the ground from when it was launched. So there you go.